This is exercise 4.7, question 9. In this question, we're told that ABCD is a quadrilateral in which these four angles at ABCD, they're all alpha, that they're all equal. We have to prove that ABCD is a rectangle. Now, the definition for a rectangle is that a rectangle is a parallelogram in which one angle is a right angle. So I'll bring that definition in. So a rectangle is a parallelogram in which one angle is a right angle. So what we're going to have to do to prove that we have a rectangle here is to prove that one of these angles is a right angle, and we need to prove that this quadrilateral is in fact a parallelogram. Okay, we'll start with what we've been given, that ABCD is a quadrilateral, which is a four-sided shape. Now, the only rule about a quadrilateral that we can use is that the angle sum of a quadrilateral is 360 degrees. So we'll just use that now. So we can say that alpha plus alpha plus alpha plus alpha, in other words, that 4 alpha is 360 degrees, reason being angle sum of a quadrilateral. Therefore, solving that equation, we can say that alpha is 90 degrees. So we have proven one part of this already, in that we've got one angle which is a right angle. We've actually proven that all of them are right angles. The next thing we need to do is prove that we have a parallelogram. Now, parallelogram is a four-sided shape in which opposite sides are parallel. Okay, so we need to prove that AB is parallel to DC, and we need to prove that AD is parallel to BC. Now, the best way to do this is using either alternate, co-interior, or corresponding angles. We can see here we can really only use co-interior angles. Now, we can see that this angle here at A plus the angle there, let's just do these ones first. The angle at A and the angle at D are both 90 plus 90, which is 180. Hence, we've got co-interior angles there, and I could draw out this little C there. So we'll write that up first. Now, the first thing I'll actually do is just put in all those right angles first. So we've got a right angle in down there. So I've just put in 2 right angles there, and if I draw a C here, we can see that these 2 right angles are co-interior, that's their position, and they are also supplementary because they add up to 180. So we can write that out. So we've got that angle BAD plus angle ADC is equal to alpha plus alpha, which is 90 plus 90, which is 180 degrees. But we can also say that angle BAD and angle, so that angle there, and angle ADC are co-interior angles as well. Hence, we can say that AB is parallel to DC because these 2 co-interior angles that we're talking about are supplementary. So we'll mark the diagram with the parallel lines, and I'll mark them in blue to keep these blue right angles to show that they match up with these 2 parallel lines. So we can see the co-interior angle here, and that these 2 angles, alpha and alpha, add up to 180, so they're supplementary. So we've shown that one pair of lines are parallel, or one pair of sides are parallel. We now need to do the same with these other 2 sides. So now we need to show that AD is parallel to BC. Now we can do the same thing again. So again, this angle at A and the angle at B are both 90, and therefore they both, the 2 of them add up to 180. They're also co-interior, hence we can say that AD is parallel to BC. So we'll just write that up now. So we've got that angle BAD plus angle, so angle BAD plus angle ABC is alpha plus alpha, which is 90 plus 90, which is 180. And I'll just mark those right angles in on the diagram. So I've marked those right angles here in black. So we've got that angle BAD. So we've got that angle BAD plus angle ABC is alpha plus alpha, which is 90 plus 90, which is 180. We also know that angle BAD and angle ABC are co-interior angles. Hence, once again, we can now say that AD is parallel to BC because these two co-interior angles are supplementary. I'll just mark those in on the diagram in black. So we can see these co-interior angles. I'm just drawing a sideways upside down C, and that AD is parallel to BC. So basically we've proven that we have two pairs of opposite sides that are parallel, and that is enough now to prove that we have a parallelogram. So we can say that that therefore ABCD is a parallelogram because we've got two pairs of opposite sides that are parallel. But we also already know that all those four angles, but we can just state that we know one of them, but we know that angle ABC, for example, is 90 degrees. So we've basically shown everything that we need for this definition of a parallelogram, which is that a rectangle is a parallelogram in which one angle is a right angle. We've already proven it's a parallelogram. We've said that we've got one angle is a right angle. Therefore, we can make our conclusion, and we can just say that ABCD is a rectangle because it is a parallelogram with one angle, which is a right angle. And that is the end of that proof.